Hello everyone. I am today teaching around 35 data analysis, data mining, variable recoding, new variable creations, categorical variable creations from continuous variable, and deleting missing values, creating new ID from the existing ID. So these are the things I am going to discuss today. This will be the first lecture consisting of around 35 data mining and data analysis variable recording problems using Python. So let me go directly to the Python. This is the Python file. It is known as the class practice Python code file. In this file, there are Python codes, and the problems that I'm solving in here are mentioned in this Word file. So this is the week 4. This is the week 4 um, class practice document Word file. In this Word file, there is around 34 problems. For example, first problem is set up working directory in Python where data was saved. And then second problem is read the class practice data to Python and denote it as a D1. So what is the class practice data? Class practice data is a simulated data. Data is simulated in a longitudinal framework. It has a number of uh, variables that are named as a race, income, age, smoking status, systolic blood pressure, and height, weight, all of these things. So the data was simulated in such a way that minimum number of measurement for a subject for a person is 2 and maximum number of measurement for a person or subject is 10. So this data has around 27 variables. So these are the variables that you are saying: ID, race, income, age, smoke, SBP, DBP, height, weight, and last few variables are HDL, LDL, pulse, waist, number of login, time, and event. So these are the Word document, and this is the Word document, and that is the Python script file. So let me first run these packages. There are line number 5 to 8. I am running 4 packages or importing 4 packages in Python. Okay. So what I want to do, I am running line number 5 to 8. These are nothing but importing packages. I am importing packages that are built or that built by some other people. Okay. So data has been imported in this format. So I highlighted line number 5 to line number 8, and then I hit Control Enter in my Windows computer. You see all of these code are now in the console. Console is the output window in Python where we get all the output as well as our graphs. After doing this, now I want to check what is my current working directory. My current working directory could be obtained by running line number 12. So that means by default, what directory this Python console will get instantly. What is the default one which I'm checking now? I found that it is user MC264 desktop SBU CS54 504 and week 4. Okay. So this is my current working directory. So now as it is my current working directory, I do not need to run the line number 16 because line number 16 directory is mentioned in here. Okay. So now again, let me run it. We will see these things is running. Now these data, class practice data is saved on this week 4 folder of the SB week 4 subfolder of the SBU folder. So SBU folder CS504. Within that folder, there is another subfolder week 4. So this is what folder I have saved class practice data. So I run it. So data is run now. This is one option. Or another option, without declaring the working directory, you can directly read the data by running the line number 22. So that is the another approach. Okay, my data is now imported to Python from my saved folder. The data known as the class practice data is now imported to Python and known as the D1 data. After bringing D1 data, so I already completed question number 1 and question number 2. Now question number 3, check the number of observations and variables in the D1 data. So D1 data, now I want to see the number of observations and variable. D1 data, if you run np.shape, then you will see the output 20,900, 25. That means the D1 data has 20,900 rows and 25 columns. More specifically, in a statistical sense, the data D1 has 20,900 observations or record and 25 variables. And then if you want to take a look at the 5 row of the data, if you run the line number 27, then you will see 5 rows, 0 to 4. So Python first row is denoted by 0. That is the nature. But in R software, first row is denoted by 1. Okay. Now, question number 4, I want to sort the columns by alphabetical order. Now, the output that we are seeing in the console from the Python code on line 27 is the data D1 that has a variable ID, race, income, age, smoke. If you take a look at the variable name, they are not alphabetically ordered. So I want them to be alphabetically ordered. In order to have them alphabetically ordered, you have to run the line 32. If you run the line 32 and then check the head, then you will see the variables is now alphabetically ordered. Now see age, arms, BMI. So here breast means chest measurement, right? Chest measurement breast, and this is a categorical variation. Might have a chest size uh, 22, uh, altogether round it is 22 or 24, something like that. So when you see breast is a categorical, so that means, yeah, originally it was in centimeter or sentiments, either it was in sentiments or meters, but it has been converted to a categorical variable. Okay. Now, suppose someone want to see the data frame is sorted in a reverse alphabetical order. Reverse alphabetical order means like the oh, column name that started with the letters G, Y, X, W, that will appear first. In order to do that, if you run the line number 38 and 39, you will see now see WT, WM, West, these are coming first. Okay. So now question number 6 is telling you sorting the data frame by age variable. For example, if you take a look at the data, this is the data that has started with the age 9.35, 10.34, 11.28. But if I run the line number 44, you will see, so entire data frame will be arranged in a ascending order. So all smallest A's will appear up until the largest A's, or the So for smallest to largest. Okay. So let me run it by running this. If I run this now and then want to show you what is the age. Now take a look at the age is coming this way: 8.9, 8.96, 8.97, 8.9. Previously, if you take a look at this data, see the age is coming 9, 10. That is coming in the format of each individual, because this is the longitudinal data or panel data. So each person ID, he is appearing once in a year. So that is why there is a jump of 1 year between ages for a person. But when you sort the data in ascending order, you will see the age is appearing in ascending order. Okay. Now come to the question number 7, which is called how to sort data frame by two variables. So first I sort the data by ID. That means smallest ID will be taken. After that smallest ID taken, corresponding to smallest ID, age variable smallest to largest will be arranged. In that way, data frame will be arranged from smallest to largest. But first, smallest to largest sorting will take place on the ID variable. And then for corresponding to each ID variable, age variable will be sorted. So now if I run these things, and then if we want to take a look at this for S4.head, you will see this is the results. So it is coming by the ID 5,000, 50,000, 50,000 and their age. And then it will go to the next one, and then it will go to the next ID and their age. So this is the way data frame can be arranged smallest to largest. Okay. Now sorting the data frame by age and ID variable with missing value appearing first. So if suppose you want to sort the data frame by two variable, first one is ID, first one is age, and then second one is ID. But within the age variable, if there is any missing value, that will appear first. That will appear first. If you want to do that, you have to run the line 55. If you run the line 55, in that way, you will see your S5 data, which is created from D1 data by sorting the D1 data frame first by age and then by ID variable under the condition that missing value appears in the top. And then it will be your data S5. Now, if you take a look at the head of the data, you will see this is the data. So are you seeing I put here age, right? So that is why nan is coming. Nan is coming. Okay. So it is short by age. Where is my age? So age is missing. Age and age is missing. So that is why I am not available. Age is missing. Is not available first. It is coming like this way. Okay. Not available, come by first. So this is the way it is coming. Okay. So similarly, if I want my missing value to appear last, then you have to run the line number 60. Okay. I just don't want to show you it again. But if you type S6.head, then you will see the output is similar. Now what I want to do from this data, I want to take only first visit for each subject. What does this mean? Take a look at that. I want to take you a little bit back in here. Are you seeing this is the ID number? So that means this person is the same person. 50,000, his ID number is 50,000. And if you take a, there is a visit variable. So this is his first visit. This is his second visit, because first visit is appearing at age 9.35. Second visit of the same person is taking place is 10.34, 10.34 within 1 year. And then third year, this is happening for this person. So what does this mean? So this means repeated measurement. So suppose 100% has been identified as a person to investigate a disease. And but these 100 persons are asked to come once in a month, and then they will be followed for a 1 year. Then that means each person will have 12 measurement because they are coming once in a month, right? So 100%, 12 measurements, so data will be 1200 rows, 1200 rows. Similarly, these data 2300 persons, but they are measuring like on an average 10,000, 12 times 1 year. Sorry, they are follow up for 10 years. So that is why there is around 20,000 or 22,000 data. In these data, a person is appearing multiple times, but once in a year. So if a person appear multiple times in a data, that data is called the longitudinal data or panel data or repeated measurement data. From this repeated measurement data, I want to select only first visit. I want to select their first visit. How can I do that? See, first I need to sort the data. D1.sort values. D1 is my data, and I sort values by ID and age variable, ascending order true. After sorting this variable, I name it as a S7. From this S7, I do what? Drop duplicates. Subset ID keep first. Any duplicate value you should drop by keeping only the first one. Now you see significant reductions of the DF1 data frame. For example, if you now if you take a look and piece the package and shape, and then if you take a look at the DF1, you will see 2379. But previously there was how many observations? Previously there was 20,900 observations. This 20,900 observations consisting of 2,379 persons, but this 2,379 person has a multiple measurements once in a year for the 10 years. Okay. So now you have seen how to subset the data. Alternatively, instead of running 66 and 67, we can also do these things. DF1 will get the same results. Take a look at this one. DF1 is same results. Okay. DF1, if you take a look at this, it is same. Okay. So now after doing this, if I want to do the last one, then you have to run this line of code, okay? So line number 75 and line number 77 is giving us the same result known as the df2.head. df2.head. They are now taking the person last measurement. So when the persons came, are you seeing last measurement? All the ages is 18, 19, 19, 20, something like this. Their ages is something like this. Okay. But previously, when I take the first measurement, their age was 8.9 or 9 or 10, something like this. Because this is a 10 years follow-up study. So 10 years follow-up study. The first data, first measurements are taken when they are 9 or 10 years old, and last measurement was taken when they are 19 or 20 years old. Okay, so that is why you see the ages is changing in this case. Okay, after this, now in the D1 data, if you want to know the name of the columns or variable, you just need to run these things. So D1 data has these variable: ID, race, income, age, smoke, SBP, DBP, height, weight, waist minimum, BMI, visit, sugar, breast, hips, arms. Breast means chest measurement, chest, arms, total cholesterol, triglyceride, LDL, HDL, pulse, waist, number of logging, time, event. These are the variables. And if I want to take a look at the entire data, then we have to run this. And then if we want to see the data is a matrix format. Matrix means row and columns, or data is a data frame format. Data frame format means data has a column name as well as row number. That is the So this is a data frame format. So it is clearly written the D1 data is in a data frame format. Okay. After this, now if I want to check like the types of the variable, then whether the variables are integer or numeric, that could be obtained like 64. Float means continuous. Okay. Float means continuous. Okay. I want to take a look at the first five rows of the day on data. And I also want to take a look at the last um, five rows of the data. So that is the way. If you want to take a look at a first 100 rows, then this is the result. And then if you want to take a look at the last 100 rows, so that is the way you can do this. Now, I have a ID variable. ID variable, I do not want, suppose I am a manager and this is the very confidential informations. I want to give this data to the people who are working under my supervisions. As they are working under my supervisions, I do not want the confidential informations of my client to be disclosed to the other people. So in this way, I can hide their original ID. So original ID, I am changing by subtracting 49,999. 49,999, I am subtracting from the original ID, and new ID variable has been created. So now, if you take a look at the D1 dot head, if you take a look at the D1 dot head, then you will see this is your data. Okay. Now see, original data was 50,000 new, sorry, original ID was 50,000 of a person. Now his new ID is 1. So now the ID number has been changed. Okay. As I am the manager, I know I have changed the ID number by subtracting a unique number 49,999, and then ID has been changed. Now, original ID I can delete. So now if you run the line number 106, the original ID has been deleted. See, this is the original ID and this is the new ID that I have created. Now I deleted original ID. Take a look at that. Take a look at that. Original ID has been deleted now. See, ID variable is no longer in here because I ran the line number 106. I deleted original ID. So now the data is de-identified. Okay. The person whom I will give this data for do the further basic analysis and statistical modeling analysis, the things that will be done by the people who are working under my supervisions, would not be able to identify each person because their identity or their ID number has been changed. Okay. So in that way, any data, confidential data, you must not share the ID number to the people. Instead, you can create a new ID, and that new ID is not identifiable. You can send it to the people who is working under your supervisions. Now take a look at that one. I have shown that one. So original ID is no longer in there. Now I want to find the summary statistics. What is summary statistics? Summary statistics means suppose there is a continuous variable weight or height. If this is the weight and height of a 20,900 people, what is their minimum height? What is their maximum height? What is their first quartile height, second quartile height, and then third quartile height? What is their average height? These are the measurement known as the 5-number summary statistics, which can be obtained by running line number 111. And if you take a look at that, this is income, race, event, new ID. This is what, and then you find the mean, standard deviation, minimum, 25th, 50th. 25th percentile means first quartile, 50th percentile means median or second quartile, 75th percentile means third quartile, and maximum. Okay. So by using this, you can find the summary statistics of the data D1. Okay. Now uh, instead of taking a loop for the summary statistics for the entire data frame, I am interested to find the summary statistics for one or two variable, which could be obtained by using this SBP. SBP means systolic blood pressure and DBP means diastolic blood pressure. When we go to the doctor, doctor put blood pressure machine in our hand, and then immediately two readings show up. Two reading. One is up, another one is down. Up one is called the systolic, down one is called the diastolic blood pressure. Okay. So if a person is identified with high blood pressure, both systolic and diastolic blood pressure reading will be high. Okay. If high one is bigger than 140, then he is identified as a hypertension person or high blood pressure. If low one is below 60, then the person is identified as a low blood pressure. Okay. So this is the way we can find like summary statistics. If I want to find the summary statistics of a variable, then we can find describe. So if you are interested to find the summary statistics of just only one variable, then this is the way you can write. Sorry, this is the way you can write. Let me put it in there, copy these things. Summary statistics of a variable, oh, which I already discussed in question number 20, summary statistics. Okay. Now, suppose there are 25 or 26 variable. How many missing values corresponding to each variable? How can I find that? That could be obtained by running line number 125. Okay. So if I run the line number 125, you will see race has a 0 missing value. Income has 1158 missing value, 1889 missing values. This is the way you can identify that total cholesterol. So TG, triglyceride has the TG stands for triglyceride. It has the highest missing value. Total cholesterol has the second highest missing value. HDL and NDL at the third and fourth highest missing values. And then after that, smoke has the fifth highest missing values. And then WM sugar has the sixth. And this will continue in this way. Okay. So how to find the number of missing value corresponding to each variable of your data can be obtained by running the line number 125. Okay. Now, data frame, right? It has a rows and column. Corresponding to each row, how many missing values are in there? How can we find that? That could be obtained by running this code. D1 dot is null dot sum axis equal to 1. Axis means I want to find the sum by column. Okay. Axis equal to 0 means row and axis equal to 1 means column. Take a look at that. I am summing over the column. So first row, row number 1, but it has a multiple column, right? So that means I'm summing over the column. Careful about that. So now if I run this, a new variable name nmiss will be created. And then if you take a look at data d1.head, d1.head, then you will see this nmiss. So that means first row has only one missing values. That means first row has only one missing value. Second row has 4 missing values. Third row has 0 missing values. Fourth row has 4 missing values. Fifth row has 0 missing values. So why I am doing these things? In order to find like which row has a more missing values. Okay. So suppose if we see that a row has a 25 missing values, then I can say that, well, that row must not have any data. So we cannot do any multiple imputations. So that means those type of rows should be deleted completely because that row does not have any value. because there are 25 columns. If any entry of the NMIS column has 25, so that means that row does not have any missing value, does not have any value. So that means each entry of that row has all missing values, each entry. So that is 25. So we can delete those things. That is the one options. And another options that if you say that, well, average number of missing is 5 or 6. So you can say that, well, any row, or you can say that n miss is greater than 5, delete those row. That is the reasons we have created this variable. Okay. After that, um, deleting rows that has missing values. So now any row in the D1 data has missing value. I want to delete that row. So now it will be my D2 data. Take a look at the D2 data. Original NP dot shape. This is the original data D1. It has 20,900 rows. After deleting row that has at least one missing values, take a look. Significant reduction. 20,900 to 942 rows. Original data D1 has a 20,900 rows. Now, any row that has missing value, that row has been deleted. Now, the number of rows reduced from 20,900 to 1,942. Okay. Now, if I want to find the summary statistics for the complete data, D2, which D2 is the complete data. That means in that data D2, there is no entry that has missing value. Every entry has the values. Okay. So I want to find the standard deviations for the D2 data. So this is the way you can find the standard deviation. Now I want to find the standard deviation for the only continuous variable. So race, income, smoke, breast, waste, event, those are discrete variable. And then C, I selected them as the irrelevant, and then I deleting them, deleted. Variable for variables in D2 dot columns. If D2 is my original data and D2 data dot columns, if variables not in the irrelevant. So that means this relevant means I am selecting from the D2 data only relevant variable by ignoring irrelevant variable that I have specified in the line number 145. Okay. Now, if you want to run these things, you will see this is the standard deviations for remaining variable. Each of these race, income, smoke, breast, waste, and event are not in here. These are not in here. Okay. So now if I want to find the individual mean, minimum, standard deviations for a variable from the D2 data, which can be obtained by running line number 151, 52, and 53. Okay. Question number 26 is doing two columns. For example, take a look at this. I don't know whether D2 dot head, D2 dot head. Suppose here age and time. I want to find the average of age and time and want to create a column in there. Okay. So what I am doing, SBP and DBP, I want to find their average and want to create a column known as the EBP, average blood pressure. So SBP plus DBP divided by 2, I am computing an average blood pressure. But in clinically, the average of the SBP and DBP does not make sense. Remember, I'm doing it in order to teach you how to find a column by finding the average of the two columns. This is what you are learning. No meaning of finding the average of the SBP and DBP. SBP is the highest blood pressure measurement, and the DBP is the lowest blood pressure measurement when blood pressure machine is put to our hand, and finally machine give us two reading. That is the thing. So on the line number 157 and 158, we are finding how to find, we are trying to find the average of the two columns. Average of the two column. Now take a look at this one, D2 dot head. If you take a look at that one, you will see there ABP. So this ABP is the average of SBP and DBP. Now, in order to convince you, I want to show you side by side presentation or demonstration of SBP, DBP, and ABP. So I just take this one, take that one, and see. If you find the average of these two, just find the Control V. I see I got 93.25. Are you seeing 93.25? So this is what? So this part I have shown in order to convince you that D2 data has a ABP variable where each entry is the average of these two entry. Okay. Now come to the question number 27. Question number 27, what I'm doing, there is the ABP variable. From the ABP variable, I am creating a categorical variable. ABP is a continuous variable. From the continuous variable, I am creating a categorical variable. For example, if ABP value 0 to 85, then the level will be 3. If ABP values 85 to 100, then the level will be 2. If ABP value is greater than 100, the level will be 1. Okay. So ABP values is in there. There is a ABP values. Now I want to create a BPC, blood pressure category variable, and that will be 1, 2, 3. That 1, 2, 3 will be determined from the values of this. When these values falls in this range, okay. And then I put here maximum 1. So I want to take the maximum of ABP and then putting a +1. If you do not want to put +1, that's fine. But +1 makes sure that after that, there is no maximum value on the ABP. So I run that one. After running that one, I create 0 to 85, one block, 85 to 100, another block, and 100 to ABP limit is another block. Within block, 3, 2, 1 fall. Okay. And then finally, take a look at that. 93, right? 93 falls where? If you take a look at that, 93 falls in here, right? 85 to 100. 93 falls in here. So that is equivalent to 2. Are you seeing 2? This is 2. Okay. Enough. So now come to the question number 28. What I'm doing, I'm subsetting the D3 data by taking, I am subsetting D2 data by taking TC value greater than 162 and WT less than 68. I'm subsetting the data D2 data, I'm subsetting D2 data and creating a new data D3. In that D3 data, the total cholesterol value, each entry of the total cholesterol must be greater than 162. Each entry of the weight must be less than 62. That is the way data has been subsetted. Now I want to find the question number 29, the cross tabulations. Cross tabulations means how many categories 1, 2, 3 in the BPC variable. BPC is blood pressure category consisting of 3 levels, 1, 2, 3. I want to find their frequencies. More specifically, I want to know how many one category, how many 2 category, how many 3 categories. If this is one, we find that there are 126 level 3, 1100 with level 2, and 716 with level 1. Okay. After this, this could also be done by running the 186. Same thing you will get. Now I want to find the cross frequency of the race and BPC variable. So BPC variable and race, it is called the contingency table. That means cross tabulations. Column has one categorical variable and row has another categorical variable. If I run the line number 190, we see that race has two levels, 1 and 2, and BPC has three levels, 3. And we see that race 1 with BPC category 3 has a 6.8. Okay. Okay. Now I want to find by race. So I want to find the mean of the entire data frame by race variable. So race level 1 has mean for each of the variable. Race level 2 has a mean corresponding to each level of the data frame. So this is the mean age of the race 1 is 13.06. Mean age of the race 2 is 12 point this. Okay. Mean age, mean age of the mean age of the mean average blood pressure for the race 1 is 97.86. Mean average blood pressure for the race 2 is 96.75. So this is the way other mean things could be computed. This is the standard deviation one, and that is by race SBP, and this is by income group, and then finding the variance for the entire data frame by the income group. So income has, now you can ask me why like this way, because income has 9 level. Level 1 has a mean age 1 point, sorry, it is not a ace. I'm sorry. It is a variance. I was thinking that it could be ace because it is a variance. I was stuck when I see the 1.29. So I am not finding mean, I'm finding variance. So that is why it is 1.29. Variance for the A's corresponding to income level 1 is 1.29. Variance for the A's corresponding to the income level 2 is 1.27. Okay. Okay, and then finally, question number 34 is showing you how to subset the data by selecting only unique ID. By running the line number 210, we are doing subsetting of the D2 data by selecting only unique ID and then dropping the duplicate ID. Okay, dropping the duplicate ID. Okay. So if you take a look at this np dot shape D2 data, D2 data, this is like that. Now if you take D3, it will reduce further at 1400 something, 1440. In this case, there is no repeated measurement. Okay. So there are 34 questions in this class or in this video. So that will give you the uh, informations about how to write Python code in order to subset the data by variables, how to record variables from continuous to categorical, so how to delete missing values, and how to subset the data on multiple characteristics like height, weight, all of these things. So that's it. If you have any questions, you can ask me by email. Thank you very much. Bye.